We don't know what's out there. People might give you an answer, but they will probably be wrong.
Einstein's theory has withstood the test of time for almost a century. If there's one data point out of place, we would have to throw the entire theory out. Everywhere we look in the heavens, Einstein's theory comes right on the spot.
But less than a year after it was published, theorists realized general relativity predicted something so profoundly troubling, many believed it couldn't exist in the real world. Anything very heavy and very small would create such a strong gravitational field that space and time would be bent and twisted to breaking point. General relativity had predicted the existence of black holes. And it didn't just say that they would exist. General relativity allows us to imagine what it would be like to travel into one. Einstein hoped that general relativity would form the framework for a new understanding of nature. But at the heart of its description of a black hole, theorists found a problem with Einstein's mathematics. Something so disturbing, his theory breaks down completely.
There's a monster.
In the extreme gravity at the core of a black hole, Einstein's equations spiral wildly out of control.
After a very long, tedious calculation, I mostly get zeros, but the non-zero term is given as follows. M is the mass of the black hole. R describes the distance from the black hole. Here is the problem. Right there, when R is equal to 0, the point at which physics itself breaks down. So 1 over R equals 1 over 0 equals infinity. To a mathematician, infinity is simply a number without limit. To a physicist, it's a monstrosity. It means that, first of all, gravity is infinite at the center of a black hole, that time stops, and what does that mean? Space makes no sense. It means the collapse of everything we know about the physical universe. In the real world, there's no such thing as infinity. Therefore, there is a fundamental flaw in the formulation of Einstein's theory.
According to Einstein, then, all the mass of the black hole is contained within an infinitely small point that takes up precisely no space at all. This impossible object of infinite density and infinite gravity is called the singularity.
We know what a singularity is. A singularity is when we don't know what to do.
To me, what's so embarrassing about a singularity is that we can't predict anything about what's going to come out of it.
The singularity at the heart of a black hole is both astronomically heavy and infinitesimally small. To understand it, quantum mechanics alone wasn't enough. It needed to be extended to describe gravity. A theory called quantum gravity. The most obvious way to create such a theory was to make a quantum version of Einstein's theory of relativity. Proof of its success would be a new understanding of black holes that explained what really happens in a singularity.
This is the Lagrangian of Einstein's theory, four-dimensional determinant of the metric tensor times the contracted Ricci curvature tensor.
When physicists tried to combine the two theories, they encountered a familiar problem.
I insert this into the probability that gravity will move from one point to another point. When I actually do this calculation, I get yet another integral. And when you do this integral, you get something which makes no sense whatsoever. An infinity. Total nonsense. In fact, you get an infinite sequence of infinities. Infinitely worse than the divergences of Einstein's original theory. This is a nightmare beyond comprehension.
The search for a theory of quantum gravity had fallen apart, because quantum mechanics and general relativity proved to be totally incompatible.
I think the most embarrassing problem we have in theoretical physics is that we have these two different theories which won't talk to each other. We have Einstein's theory of gravity, which beautifully describes the very big and the very fast. And then we have quantum physics, which very successfully describes the very small. And yet, clearly nature has one unique way of operating. It's not schizophrenic, and we humans just don't seem to be able to find that way.
The failure of these two great theories to understand black holes means they are, at best, an approximation to the laws governing the universe.
The equations no longer make any sense. And nobody knows exactly what we're supposed to do about that.
Well, it's awful. It means that physics is having a nervous breakdown. It means the collapse of physics as we know it. You know, something is fundamentally wrong. Nature is smarter than we are.
If we want to understand the universe, we must understand how quantum mechanics and gravity can live together. And so that's our challenge.
So it's quite a big question.
It's a huge question. There aren't questions much bigger than this. We don't understand.
For nearly 100 years, physics has been able to explain the universe around us. General relativity perfectly describes the motions of stars and galaxies. And the world of atoms is beautifully explained by quantum mechanics. Yet the discovery of black holes means we don't fully understand anything.
Quantum gravity is the name that we give to the solution to this problem. We don't really know what quantum gravity is.